first thing I'm going to do is I'm going to create a function. It's going to be div by 0. Oops. All right. Does anybody know why first of all, does anybody recall what the static keyword means? Jesse?
You mean that it can be seen throughout anything that uses that package or anything inside of the, describe it.
Yeah, so what it is, yeah, Sean, did you want to add to that?
It always behaves the same way in every queries.
Well, in a sense, right? Yeah, Andrew, you want to add a little bit more?
Well, like public static void main, that thing, even in Eclipse, if you're on like some other class and you hit run, it goes and finds it, right? So you can see it everywhere. So is that what static does? It allows you to see that method from everywhere?
Without what?
Without its name changing.
Do we have to have it associated with it something?
No. Watch it.
Without,
Yeah, so here's the thing. The big deal about this is we don't have to have an object of type whatever, in this case exceptions, in order to call this method. So for instance, if you want to do square root in your program, right? You call math because you have to specify where you're getting that from, so the math class, and then you just do it SQRX, right? Is there an object here?
math.
Well, it's calling that class, but the thing is it's static, so it doesn't need it. So I don't have to go math m equals new math, right? And then go m dot square root. That's a little bit cumbersome, right? Because we don't need an object of type m. We just want it to perform some function, right? Now this is an artifact of the fact that Java is completely object-oriented. And so to get around the fact that sometimes you just need a method to do stuff without it being associated with a class. So what it does is it creates static methods. So I don't have to create an object of type math in order to call this function. It's independent, it's associated with a class, but it's independent of that class. I don't need an object of that type, that class. And so when I have static void main, and I have another method that's inside of that class that's going to be used within this, I have to make this method static as well. Okay? All right. So we're going to do a div by 0.
Wait, say that again?
Yeah, I'm sorry.
Yeah. That was like a 4-second delay on my brain. You have to make it static, right?
Okay, so if you have something that's independent of a class, right?
Yeah.
When you call another method within that same object, right? Because we're creating, we have this object called exceptions.
Yeah.
If we're going to call another method within this static main, we have to make it static. It has to be independent of a class.
So static methods are independent of a class, or are they associated with a class?
Within this class, if we have a main, maybe I shouldn't even open up this can of worms.
Too late.
I think we're getting down a rabbit hole, and we don't need to.
Okay.
The point is that if you have a static method, and it calls another method in the same class, and you have to make that method static.
Okay.
Yes.
So every single method in the math class is a static method, and that's what allows me to just say math dot
Yep.
this thing, math
Yep,
dot that
right.
thing.
This is slightly different in the sense that we're creating this main, and we're going to be calling other methods within this same class that has main. But in order for us not to have to say exceptions, create an object of type exceptions in here is equal to new exceptions, and then say, let's say that it's exceptions E is equal to new exceptions, and then E dot divided by 0. To get around that, what we're going to do is we're going to make it static.
So if it's inside, you have to make it static. If it's outside, you just do it.
Unless I created an object of that type, and I don't want to in this case, okay? The way I could get around it is this, is okay, so here's what I could do. I could create an object of type exceptions.
So you're creating it south, basically, yeah.
Oops. Exactly. And so, and then I could say new exceptions. And then I could say E dot div by 0. I don't want to do that, because it's just more code than I don't need. And so if I make it static, I can call it within this method without having to do that. And so what I can do is I can get rid of all the rest of this stuff, okay? And then do it like that, okay?
Was it fussing at you just a minute ago? What happened?
Because it's static and it was
Because
saying
it's
I don't need to
static.
do, I don't need to do
Okay.
that, right?
No.
If I got rid of this keyword,
Yeah.
I would have to do that.
That's what I was just curious.
Yeah, okay? All right.
Without going too far down this rabbit hole, if we were in a different class, could we call div by zero if it was static or no?
Yeah, we absolutely could. We could say exceptions dot div by zero, as long as it's in the same,
Okay.
package or whatever.
It just allows it on there.
Yeah.
I was gonna say, would you have to do like an include statement at the top of the program to bring in everything that has
If it
that
was in a,
package?
if it was in a different package, yeah, or something like that.
Okay.
If it wasn't in the same folder that you're creating,
Okay.
yes. We could do it independent of this. All right, let's press. So what we're gonna do is we're gonna do this. So we're gonna try, and what we're gonna do is we're going to do, well, actually, let's do it without that first. Let's do it without this. We'll just see what happens when we do this without actually having an exception. Okay? And then we're gonna do a sys out so we can see what's going on here. And we're gonna say the value, oops. I really should have fixed this one. All right. All right, so the value of j divided by 0 is, and then we're just going to do that. We're going to divide j by 0. Okay? So what should happen? What are we expecting to have happen at this point, Stephanie? What should happen if we try to divide by 0? Stephanie?
It's gonna pop an error at you.
Okay, right, it's going to pop an error at you, right? Because you can't do that. Mathematically, it doesn't make sense, right? You can't divide things by 0. Well, okay, yeah. We're just talking about, well, yeah. Okay, so there you go. So what happened? We got an exception, right? Now here's the problem. Okay, so first of all, my next question is, Clay, is that an arithmetic exception? Because that's what was thrown, right? An arithmetic exception was thrown. It's part of the Java.language or lang library. Is that exception checked or unchecked?
I don't remember, let's say unchecked.
Why do you say that?
I don't remember the difference between checked and unchecked. I think is checked when you're basically have a try catch and you are trying to catch it. That's a checked one, but that is unchecked and therefore.
If you have a checked exception, you have to make a try-catch block or use a throws declaration. You have to handle it. That's the whole point of checked exceptions. You can't ignore it. Runtime exceptions you can ignore. And so you ask the question, when should I use a runtime exception? When should I use a regular exception? Checked versus unchecked. It's really a design issue, and it really depends upon what the circumstances are. If you have an exception that's going to be really a problem for the program right down the road, it's probably a good idea to go ahead and make it a checked exception. But some people don't like to have their hands tied. So some programmers gripe at that because they don't want to have to deal with those things all the time. So it's really, it's a balancing act is what it is. It just depends, yeah.
So check literally means that the programmer, as they were starting off, anticipated that this could possibly happen, so they made a checks and balance system for it.
Yep.
If something was unchecked and it was an error, you look to the programmer and say, why is this error happening? And the programmer would look back and say, well, there's really no way I could have anticipated that that particular error could have happened. So
Right,
I didn't create a checks and balance for that particular error.
Right, and sometimes it's a matter of, maybe it's not efficient to check that exception.
You could
Maybe it's
write
just
checks
easier-
for a
Yeah,
billion different
yeah,
kinds
exactly.
of exceptions, it would just be a waste of that time.
Right, exactly.
Okay.
So you have to just really, again, it's one of those things where you have to be, you just have to understand what the situation is and, use your best judgment. And that always isn't the case, but that's just the way it is. Like all design issues, it's not necessarily, you can't say it's one way or the other. It just depends upon the situation. Okay, so what we're going to do is we're going to catch this thing. And we're really not gonna do a whole lot with it. I just wanna show you, how we can actually handle it. Not necessarily in the best way, but we're just gonna handle it, okay? My variables when I use these arithmetic, or when I use exceptions, I usually just abbreviate the first letters of the error. There's nothing magical about that. You can call it whatever you want. You can call it Bob, you can call it George, you can call it,
Bob.
Mount Washington, whatever you want to call it, but, it's usually brief. And then what we're going to do is we're going to go ahead and we're going to, we're just going to, so one of the things that we can do is we're going to just go ahead and put out a message. And then what we're going to do is we're going to print out the stack trace. Okay. So first of all, why do you think we want to do this? Yeah, Jay.
It prompts the user with a nice message of what the error is, something they can read.
Yeah, do you think, is this complete though, do you think? Can we include more information? Maybe we can say, got an arithmetic exception into div by 0 or something like that, okay? That would probably be a little bit more complete. What is this going to do? Oh, do you remember what that's going to do?
Would you just point at?
The print stack trace?
Does that print the? I'm not exactly sure.
Yeah, Sean, do you know?
Is that like, when we're doing our debugging, like homework, that's like all the line of all the crap you
That's where you get those errors, yeah. So let's look at this real quick. Because what we can do is if we just do our dot there, and we can look at print stack trace. And you notice, guess what? It's part of the throwable interface. So what is it going to do? So what it's going to do, it's going to backtrace to the standard error stream. Okay, well that might not make sense, but it's going to print the stack trace for the throwable object on the error output. The first line of the output contains the result of the toString method. Okay. I'm going to show you an example here in a second where we're actually going to create an exception. And one of the constructors for the exception can be a string. And that string represents the message. Because remember when we talked about exceptions or the throwable interface last time? We had said there was a message that could be associated with that particular exception. We can actually set that message. And what do you think the toString method is going to return if we call it on an exception? It's going to call back that message, okay? So the first thing that's going to be printed out is that message that we're going to put in our constructor if we have one. And then it's going to do the stack trace. And that's just that call stack like we talked about last time. It's going to be the series of methods that were called in order for you to get to the place where the exception occurred. And that's what a print stack trace is going to do. Right? And so that's what we're going to put there. Now, if you look at it, it looks an awful lot like the last time, didn't it? Because by default, it's going to print the stack trace if you don't do anything else. Okay? But it's a good idea just to have that information sometimes. So we really didn't do a whole lot here.
Actually, if you don't mind me interjecting right here, as a developer in mainstream code where you've got actually thousands of classes and tens of thousands of lines, you'll have multiple calls that'll dev into a particular class, right?
Yeah.
And you'll find out the issue wasn't in the class that actually exploded, it was 4 classes up where somebody passed in an invalid value.
Right,
so
right.
As a developer in mainstream, it's really important to have this.
Yeah, to set up the messages, right? Yeah, to know exactly where it happened. To give the person who's going back 5 years after you've written the code and is run it and it throws things out of loop, out of whack, and you're trying to figure out where the error is. Thanks, Brian. Yeah, Andrew. Or I'm sorry, Clay.
Is this now a checked exception since you have?
It's not a checked. We haven't changed the actual. We're handling the exception. Okay.
Okay.
Now it's a handled exception. It's not necessarily checked at this point.
So what
In
was
fact,
the
it
difference
isn't. It's
between
unchecked.
checked and unchecked then? If you could just quickly, I'm trying to remember.
If I had a checked exception, if this was a checked exception, I'd have to use the try catch block.
Oh, like, okay, I see. If you called a method that could possibly fail in some way, okay.
If a method
It
throws a
an
particular exception,
okay, I see what you're saying.
or if it's a checked exception, like for instance, if you're doing this, yeah, Catherine had a great example, is scanner, right?
Yeah.
if you've ever done the scanner, if you've ever created a scanner to read in information, you have to have a try-catch block. That is what is known as a or a checked exception. And we're looking at this, another example here in a second. Yeah, Jesse?
Is it, the print stack, is that effectively like what the debugger does, where it says first we jump to here, then we jump to here, then we jump back into here, and it's just giving you like that path?
Exactly. It basically, remember what the call stack is. Remember we started at main, and then the method that called that, it was called in main, and then the one that was called within that method. And it's just basically going to give you a trace of what methods were called so that you can work your way back to try to figure out where this error happened. Because it might not be in the method that you just called. I mean, the one where, it could, like Brian was saying, it could be down a few layers, and you might have to pick your way through it. Now, these examples are pretty straightforward, and there's not a lot of code here. We could probably debug this in about 5 minutes, but the point is that if you have a bigger program, it's not that easy. Okay. All right, so this is an unchecked exception. We did this without this try-catch block. If it was a checked exception, we'd have to have a try-catch block. Or we'd have to put up here throws arithmetic exception. That would be the other one we can handle. But in general, you don't want to throw a lot of stuff unless it makes sense. And I'll show you some examples of that here in a second. All right. Let's look at another example. And this is, I haven't posted those. I keep I've got to post some stuff. I apologize. I just haven't. It's one of those things that I forget to do. Could somebody send me an email reminding me to post? Thank you.
Yep.
All right, so in order for us to kind of play around with it, some exceptions again, and this is going to be the kind of thing that we're going to be doing throughout the semester, we're going to be creating a lot of lists. We're going to be creating a lot of collections of things, okay? And so this is just a real, very, very simple example to test out some of the direct ideas about exceptions. Int list. So what do you think it's going to store? It's going to store integers, okay? And we're going to store it in an array. And when we get to next class, well, actually the week after, we're going to talk about the fact that there's basically 2 ways that we can implement these collections at this level. There's many different ways, but the 2 basic ways are through arrays, right? You store information in arrays, and the other one is through linked structures, usually known as linked lists. That's going to be the other way we're going to implement some of these things. We're going to talk more about that in the coming weeks. But in this case, what we're doing is we're using an array implementation for our int list. Stores ints in a list, and we're using an array to do that. So we have this array. We have this thing called capacity, which is 10, and we have a count that we're setting to 0. So, Juan, why do you think we have a capacity, which means how much stuff we can store, right? We're going to create that much space in our array. So we can store 10 items, right? So if we created this thing, and so we have spaces for 10 different integers, right? So they're going to store ints. That's the capacity, right? That's how much stuff we can. Why do we have a count? What do you think that's keeping track of? How many integers we currently have, right? Okay. So you have to understand that when we create an array, we have to give it so much space, right? We can't create an empty array which isn't taking up any space at all. We have to create an array and actually allocate space for some number of objects, or in this case, integers. Yeah.
So does capacity kind of container of the integer?
Yes. So this is going to be able to contain 10 integers, but currently we might only have 3 spots filled. So count is going to be equal to 3, right? All right. And then the only method we have right here is get, which is going to use a number to get the integer at that particular index. Okay. If in this case we could use what? We could say get 0, get 1, and get 2 without having any problems. What might be an issue though if we are empty?
No pointer exception.
Count zeros.
We're not going to be able to, yeah, right, we might get a null pointer exception. The point is that we don't necessarily know what we're going to get, right? Now, they might be all set to 0 because these aren't ints, but that's not necessarily required.